Today is the last lecture of the unit number 4. We will complete the unit number 4 in today's lecture. Okay, in the last lecture we have seen the design of nozzle and openings in unfired pressure vessel. Openings are provided in unfired pressure vessel: inlet and outlet connections, drain pipe connections, pressure gauge connections, then safety device connection, and last is a manhole. That openings we have seen in the last lecture, and we are seen the method most widely used area method of compensation. This is the most widely used in the unfired pressure vessel. Why we use that method? The area of the material is removed. Okay, that area we want to the compensated by providing the extra material. Okay, if you use nozzle, then there you are using some material will be removed, then we want to the provide the some extra material or excess material. Okay, we'll see the one by one. The portion of the shell has excess thickness. Second is a portion of the nozzle outside the vessel has excess thickness. Third is the portion of the nozzle inside as well as outside or thickness of the vessel. And last is a reinforcing pad, or it is also called as a compensation ring. Then we will see the what is the area for area method of compensation. Area of area material removed is compensated by providing additional, or we can say the excess area of the material. Shown in the figure, you have given the different dimensions. See that dimensions. You know the meaning of that dimension. Before going on that, see, first is a dA is given. dA is represented by the inner diameter of the nozzle in the uncorroded condition. There are two conditions: corroded condition and uncorroded condition. dA is given for the uncorroded condition. Then next is a DNC. DNC is the inner diameter of the nozzle in corroded condition. Then next is a S is the inner diameter of the vessel cell. Some units or some notations before that we have seen. Then TRN, minimum required thickness of the nozzle. This is given in mm. Okay, and Tn is the actual thickness of the nozzle. Also this is given in mm. Then again En is the minimum required thickness of the vessel cell. This is given in mm. Then next is the Ts, actual thickness of the vessel. C is the, we have seen, corrosion allowance. Design pressure is denoted by the Pi. N is the efficiency of the welded joint in nozzle. NL is the efficiency of the longitudinal joint in the vessel. Then there are again two new notation is given. Height is given, H1 and H2. H1 is the height of the effective compensation in nozzle wall outside the vessel measured from outside surface of the vessel wall. This is also given in mm. And what is the H2? Height of the effective compensation in nozzle. Okay, the wall inside the vessel, means both height is given inside the vessel and outside the vessel. Both dimensions are given. Okay. Then next we'll see the how to elimination of the nozzle parameters with the help of given figure. Okay, we'll see one by one. The inner diameter of the nozzle is corroded condition. It is denoted by the DNC. DNC is equal to, we can write DN plus 2C. Second, minimum required thickness of the nozzle, TRN. It is TRN find out with the help of the formula Pi into Dn divided by 2 sigma all into N minus Pi. Pi is the design pressure. Then next is a minimum required thickness of the vessel cell. It is again denoted by the TRN. We know that formula. Then how to calculate the H1 and H2? H1 is calculated the root of DNC in bracket Tn minus C, or we can take the actual height of the nozzle outside the vessel. Okay, whichever is smaller of from that both formulas. Okay, and H2 is the root of DNC into Tn minus 2C, or actual height of the nozzle inside vessel, whichever is smaller. Remember that. The reinforcement boundary limit is a ABCD. See here I have shown the area ABCD in such a way that AB is equal to, you can write 2 DNC. Then next is the area of opening on corroded for which compensation is required. It is denoted by AR. AR is equal to, we will take DNC into TRS. Then next, area available for compensation. You should check the which area is available for the compensation. Okay, area of excess thickness in the portion of vessel cell. Area of the excess thickness for the excess vessel cell is, this area is given. We will check that which area is given. A1 is given. Okay, A1 is equal to 2 DNC minus DNC into bracket TS minus TRS minus C, or you can take the DNC is common, then you will get A1 is equal to DNC TS minus TRS minus C. Okay, this equation you will get. Then next, the area of excess thickness in the portion of nozzle wall outside the vessel cell is. Second, for the outside the vessel cell, A2 is equal to 2H1 into Tn minus Trn minus C. And third condition, area of the thickness of the nozzle wall inside the vessel cell, A3 is, see in the figure I have shown A1, A2, A3. A3 is equal to 2H2 into Tn minus 2C. And last is a total area available for the compensation. You should make the summation of A1, A2, A3. Then you will get the total area available for the compensation. Okay. Then required area of the reinforcing pad. Okay, how to calculate the required area of the reinforcing pad? If A is greater than or equal to AR, compensation is adequate and no reinforcing pad is required. Remember that condition. If area A is greater than or equal to AR, then there is a no reinforcing pad is required. If AA is area for area compensation is less than or equal to AR, compensation is adequate, then reinforcing pad is required. Area for reinforcing pad, A is equal to AR minus AA, or you can write A is equal to AR minus, again AA is equal to A1 plus A2 plus A3. Okay, then next is a dimension of the reinforcing pad. How to calculate the dimension of the reinforcing pad? A is equal to ADO minus DPI into TP, where DPO is the outer diameter of the reinforcing pad dpi is the internal diameter of the reinforcing pad, tp is the thickness of the reinforcing pad. Remember that. Then there are different types of the methods are used for the reinforcement. We'll see in details. It is necessary to place the complete reinforcing material as a thin the boundary ABCD. Okay. There are two methods of the reinforcement used in a vessel opening. Okay, which two method? Balanced reinforcement and unbalanced reinforcement. In that, the prevents creation of the local bending moment with the help of that method, balancing reinforcement. There is the external reinforcement, then internal reinforcement and balancing reinforcement. Okay, again method of reinforcement, unbalance and balance. When we use the unbalancing, the reinforcing material is placed on the inside surface of the vessel wall. If the material is placed inside, then we are using the unbalanced reinforcement. Remember that. And what is the balanced reinforcement? If the reinforcing material is placed on the both side of the vessel wall is known as a balance reinforcement. Okay, the balance reinforcement is prevent the creation of the local bending movements. Okay, that's why we are prepared that method. Then next is a there are you have given the different types of the attachment of the nozzle with pressure vessel cell. Okay, remember that. Then next is a support for pressure vessels. There are different supports are required for the pressure vessel. There are two types of the pressure vessel, vertical pressure vessel and horizontal pressure vessel. First we will see the which support is used for the which vessel. Support for the vertical pressure vessel. There are you have given the two types of the support is used for the vertical pressure vessel. First is a bracket, it is also called as a lug support, bracket or lug support, and second is a skirt support. Okay, here I have shown the vertical pressure vessel supported by the bracket or skirt support. Okay, bracket or skirt support, and horizontal pressure vessel supported by the saddle support is given. Support for the vertical support vessel, bracket or lug support or skirt support. We'll see the details one by one. First is a bracket or lug support. Okay, in the bracket or lug support there are a 4 brackets or lugs we are used. Okay, because of each bracket is made up of 2 horizontal and 2 vertical plates. These plates are welded to the vessel cell and the bracket is rest on the short column. Okay, remember that. The use of the bracket support are ideal for thick walled vessel. In thin loud vessel, okay, the area where the bracket are to be attached. Okay, we are welding the pads. Okay, ideal for thick walled vessel, thin walled vessel, there we are using the bracket or lug support. This is suitable for again smaller height pressure vessels. Okay, this load is directly coming on the bracket. Okay, then how to calculate that load? We are consider the dead weight of the vessel with contents plus the wind load. Last before 2 lectures we have seen to calculate the wind load. Okay, then maximum tensile stresses are induced inside the pressure vessel and also maximum compressive stresses are induced in the vertical pressure vessel. These two stresses we want to the calculate with the help of designing formulae. Okay, all of you getting the bracket or lug supports. Okay, where we are used, remember that this is used for the thin walled vessel and this is also suitable for the smaller height pressure vessels. Then next is a skirt support. Bracket or lug support how to calculate my maximum total compressive load in the most remote support. F is equal to 4 Fw into bracket H minus L divided by N into dBc plus Wt divided by N. What is the Fw? Total wind load on exposed surface. H is the height of the vessel. We are consider this height above the foundation level. This is given in mm. L is the vessel clearance from foundation to the vessel bottom. Okay, remember that. dBc is the diameter of the anchor bolt circle. N is the number of supports, and Wt is the total weight of the vessel with contents. Already we have seen this. Second is a skirt support. Okay, where we are use the skirt support. If we have given the tall vertical vessel, pressure vessel, then we are using the skirt support. Okay, then the skirt support section has high section modulus and hence give the better resistance to the bending because of high resistance. Okay, skirt support is used for the tall vertical pressure vessel. Already I have told. Skin may be straight skirt or angular skirt. Okay, the skin of the skirt support may be straight or angular. A bearing plate is attached to the skirt support to avoiding the overturning, and it induced or subjected to the compressive stresses because of dead weight of the pressure vessel plus content of the contents of the in the pressure vessel. There we are consider again two types of the stresses: bending stress due to the wind and seismic load. Here we are consider the both wind load and seismic load. Okay, stresses induced in the skirt support is direct compressive stress. It is denoted by the sigma c. Bending stress is a sigma b. Then we can calculate sigma c is equal to Wt divided by pi dk into tk. Okay, you will get this formula. Remember that how to calculate the direct compressive stresses induced in the skirt support. dik is the inner diameter of the skirt support. dk means diameter of the skirt support, and tk is the thickness of the skirt. Again there are two types: straight skirt support and angular skirt support. Okay, stresses induced in the skirt support. Already we have seen this in the before two lecture. Sigma b is equal to m by zk. M is the maximum bending moment in the skirt support due to the wind and seismic load, and zk is the sectional modulus. Okay, then z is equal to ixx iy I max. We have find out all this formulae with the help of last lecture. Also we have seen in the combined loading. We have calculated this bending stresses also. Okay, that's why I will skip that slide. Okay, then support for the horizontal pressure vessel. Which type of support we are using? The horizontal types of the pressure vessel. Okay, there are two supports. We can say the saddle support. They again use the divided into two types: plane type and ring type. Okay, plane type for we are using for a small vessels. A plate type support may be used in a small type of the vessels, and ring type we are using the large thin welded vessel. I have shown in the figure. See, if the thickness is very small, then we are using or small vessels, then we are using the plate type of support, and when we use the ring type of the support, the large thickness walled vessel. Okay, remember that. Thank you. Then see, will remember that in that you will get any one questions for the 10 marks or 12 marks. There is a one numerical will ask on the basis of area for area method of compensation. We will see that area for area compensation method, how to solve this one. I will check that. I have select the some numerical the pressure vessel numerical. We'll see that numerical. Okay, we'll solve that numerical. Remember that you should do that numerical, because in the examination definitely you will get the numerical for the 10 to 12 marks. See, if you know the area for area compensation method formulae, then you can solve easily that numerical. Only remember the what is the given data and what is the notation of that. A pressure vessel consists of a cylindrical shell with an inner diameter of 1500 mm, di is given, and thickness of 20 mm, shell thickness is given 20 mm. It is provided with a nozzle of inner diameter 250 mm, T is given 250 mm, and thickness of 15 mm, Tn is given 15 mm. The yield strength of the material for the shell and the nozzle is 200 Newton per mm square. Which value is given? You have given the thickness, the yield strength is given SYT 200 Newton per mm square, and the design pressure PI is given 2.5 megapascal. The extension of the nozzle inside the vessel is 15 mm. What is the extension of the nozzle is given? Then extension of the nozzle is given, TP is equal to 15 mm. The corrosion allowance is 2 mm, C is 2 mm, while the welded joint efficiency is 85%. Welded joint efficiency is 85%. Neglecting the area of work, determine whether or not and reinforcing pad is required for the opening. If so, determine the dimension of the pad made up of plate 15 mm thickness. Again, thickness is given 15 mm. We want to calculate the thickness for that. See, all the dimensions are given. Read the problem carefully. What is given? See, diameter di is given 1500, ts is given 20, then again is given 250, tn is 15 mm, h2 is given 15 mm, c is given 2 mm, nl efficiency is given, okay, or n is equal to 0.85, design pressure is given 2.5, and yield strength is given 200 Newton per mm, tp is given 15 mm. X. Then sigma all, how to calculate? If you have given the SYT, you know the formula. Yes, SYT divided by factor of safety, 200 divided by 1.5. You will get the sigma all. Estimation of the nozzle parameters. How to calculate that? The inner diameter of the nozzle is corroded condition. We have seen all the formulas. It is denoted by the DNC. DNC is equal to DA plus 2C. All value is given. Put this value in that equation. You will get the 254 mm. The minimum required thickness of the nozzle wall is. What is the minimum required thickness? Pi dn divided by 2 sigma all n minus pi. Put the value. You will get that thickness. Okay. Tn is equal to, you will get that value 16.73 mm. Then you should calculate the height h1 and h2. Okay, outside height and inside height of the vessel. h1 is the outside height of the vessel, effective compensation in nozzle wall outside vessel cell. h1 is equal to, you will get the root of dnc into bracket tn minus c. You will get 57.46 mm. Then h2 is the effective compensation in nozzle wall inside height of the vessel cell. h2 is equal to, you will get the 15 mm. Then next we want to calculate the ABCD boundary we will consider. Okay, then we want to calculate the distance. AB is equal to 2 dnc. You will get the 508 mm. Then second is a estimation of compensation. Okay, here is a, we know there are 4 conditions. For that 4 condition you should calculate the total area available for the compensation. Then you will get, before going on the total area, you should calculate the excess thickness for each. Okay, first area of the excess thickness, the portion of the vessel cell. Before going on that, we want to calculate area of opening in corroded condition, for which compensation is required. AR is equal to DNC into TNC. Okay, you will get the 4249.42 mm square. Second is a area available for compensation. What area you have available? This area, we know the formula A1 is equal to DNC into TS minus TRS minus C. Okay, with the help of that formula you will get the 322.58 mm square. Then area of the excess thickness in the portion of the nozzle wall outside of the vessel cell, 2H1 into we know the all the formulas, TRN, right, in minus TRN minus C. Put the value and find out the, you will get the A21173. Similar way you should calculate the area of thickness of the nozzle wall inside the vessel cell, A3. You will get the 330 mm square. Then total area available for compensation, you can calculate the summation of A1 plus A2 plus A3. You will get the 1825.9 mm square. Then required area for the reinforcing pad, you should check the condition. As AA is less than AR, the compensation is inadequate and hence the reinforcing pad is required. The area of the reinforcing pad, we know that AR minus AA. Check that value, you will get the 2423.51 mm square. Then dimension of the reinforcement pad, DP, the inner diameter of the reinforcing pad is DPI is equal to outer diameter of the nozzle DA plus 2TA. Okay, this value will get the 280 mm. The area of the reinforcement pad is A is equal to DPO minus DPI to TP. DPO you will get 441.56. Okay, mm, the dimension of the reinforcement pad. This 3 dimension you should calculate for the dimension of the reinforcement pad. Okay guys, today we'll stop here. I have completed the unit number 4 with the help of video lecture series. I have made 10 video lectures. If you have seen that 10 video lectures, definitely you will get the maximum mark from the unit number 4. The weightage of the marks for the end sem examination is 18 for the on the design of cylinder and pressure vessel. Top 18 you will get the maximum numericals. Okay, theory part will be less. You will get the 8 marks theory and remaining marks numerical, 10 marks or 12 marks numerical and 6 mark theory. So all the best. If you have any query, then you can personally text me on my WhatsApp number. Thank you. And next lecture we will going on the unit number 5.